Lora! Come on, Lora!
La 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 Lora.
All right!
La 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 Lora. Lora, 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 the 8th grader. Uggs is super cool and 8th grader Lora.
Cheater, no cheating! Cheater, no cheating!
Aw, math.
Hey guys, I'm Lora, and this is my friend Uggs.
Oh, sorry, just taking a selfie. I look so good today.
Today, we're in Geometry, but our final destination is Algebra the Second. Today we're traveling through the foundations of geometry, but we don't know how to get there.
Does anyone know the Wi-Fi password? I can totally Google it.
How about we ask Matt?
There's something you need to learn. My pages you should turn. I'm the math. I'm the math. I'm the math. I'm the math. I'm the math.
Hello, I'm Math. Let's open to Geomistan. Right now we're in FOG. That stands for Foundations of Geometry. But that's a mouthful. To reach the next step in your journey, Geometry, you must travel down this segment. A segment is part of a line consisting of 2 points and all points between them. Now let's just look at FOG, the county we're in. Right now, we are in UPLP City. That stands for Understanding Point, Lines, and Planes. We must travel down this segment to get to MCS Town, or Measuring and Constructing Segment.
How much longer? I've been walking like forever.
Well, let's see.
Backpack, backpack. Backpack, backpack. I'm the backpack loaded up with pens and pencils too. Anything that you might need, I've got inside for you. Backpack, backpack.
Need Geomistan?
You got it. As you can see, the scale is 10 inches to 1 mile. Backpack, we need a ruler.
You got it.
Now the distance between the 2 points, FOG and MCS, is 2 inches, and according to the scale is 0.2 miles. From MCS to MCA, it is also 0.2 miles. That means they are congruent segments. You can show this by adding a tick mark to the congruent segments. Congruent segments is when two segments have the same length. The distance between 2 points can be defined as the absolute value of the difference of the coordinates of the points. The entire length of Geomistan is 6 inches or 12 miles. Length is very similar to distance, but means the distance between two endpoints of a segment. So, Uggs, we are 0.2 miles from the next county.
Well, how much farther until Geometry?
To solve that, we must use the segment addition postulate. That means we have to add all the distances from one city to the next. So we have about 1 mile left.
How much farther until we're halfway there?
I guess to find that, we need the midpoint, aka the point that bisects the line. Bisect means divide in half.
What city is that?
Let's see. Math!
Yep, I'm here to help. The city that bisects Geomistan is Artrig, which is about 6 miles away.
Thanks, Math. You're the best. Right now we're in the English forest. Some people say it might even be enchanted.
Oh, well, whatever. I'm tired. I'm just going to sit down and tweet my friends. I'm stuck. Help me. I can't get up.
Solve the problem. The problem. The problem. Solve it.
I guess we might as well solve the problem.
An angle is a figure formed by two rays or sides with a common endpoint called the vertex. There are 4 angle types. An acute angle measures greater than 0 degrees and less than 90 degrees. A right angle measures exactly 90 degrees. Obtuse angles measure greater than 90 degrees but less than 180 degrees. Straight angles are formed by 2 opposite rays and measure 180 degrees.
Now, to get to the next part of our journey, we have to cross this bridge.
Hey!
Oh no, it's the grumpy old troll.
I'm the grumpy old troll who lives under the bridge. I'm the grumpy old troll who lives under the bridge. If you want to come over, all you gotta do is this. All you gotta do is this. Solve my problem.
What's your problem?
This is my problem. Are the 2 angles complementary or supplementary? Are they adjacent or vertical angles? And are they a linear pair?
Oh no, I don't know. Let's ask Matt.
Complementary angles are 2 angles whose measures have the sum of 90 degrees. Supplementary angles are 2 angles whose measures add up to 180 degrees. Adjacent angles are two angles in the same plane with a common vertex and a common side, but no common interior points. A linear pair is a pair of adjacent angles whose non-common sides are opposite rates.
So the two angles are supplementary because 45 degrees plus 135 degrees equals 180 degrees. The two angles are also adjacent and a linear pair.
What? You actually got it? You may pass.
Hey, look at that artist's work. It's so gorgeous.
Why is she using a ruler? Oh, thank you. My art style is called geometric abstraction. That means I use congruent geometric shapes to create my art pieces.
That's so cool. Can you show us how you do that?
For rectangle, I use two formulas, one for perimeter and one for area. Perimeter is the length all around the figure. Area is the number of times congruent square units can fit in non-overlapping ones can fit inside of the figure. The two formulas I use are A equals L times W. L means length and W means width. Then for perimeter, I use 2 times L plus W. L and W mean the same thing.
What about squares?
For squares, I only use one formula, because for perimeter, all you have to do is add the different lengths. Then, for area, I do A equals S squared. S means side. And all the sides are the same length.
That's really cool, girl. Can you tell us about triangles and circles?
Of course. For triangles perimeter, I don't use an equation. Like squares, I just add the side lengths and hypotenuse length together. However, I do use one for area. I use 1/2 base times height. For circles, for the circumference, which is equivalent to a perimeter, I use 2 pi r. Pi is a Greek symbol that stands for irrational ratio that can be simplified to 3.14. R is 1/2 of the circle's length, or diameter, and it stands for radius. Then, for area, I use pi r squared.
TBH, that art's really cool, yeah.
Wait, the midget said county sign. And problem?
Again.
Once the problem is solved, you may enter.
Hey, looks like someone left their answers here.
Whoa, let's go in.
No.
Oh no, it's cheater. Everyone, say it with me.
Cheater, no cheating. Cheater, no cheating.
Aw, math. Fine, I'll give you back 1, but I'm keeping 2 of them.
Oh no, how do we solve this problem?
Yeah, we need 2 lengths to solve it.
How are we going to solve it now?
Someone need help with math? Let's solve this problem. Well, first recognize that it's on a coordinate plane. It's divided into 4 regions by an x-axis, the horizontal line, and the y-axis, the vertical line. The location of points like this one is demonstrated by an order pair. Now to solve this question, we have to use the Pythagorean theorem. In a right triangle, the sum of the squares of the lengths of the legs, the 2 sides that form the right angle, is equal to the square of the length of the hypotenuse. To find the other length, we're going to use the distance formula. The endpoints ordered pair are 0, 0 and 0, 4. The formula is the square root of 0 minus 0 quantity squared plus 4 minus 0 quantity squared. And then after that, it then becomes the square root of 0 squared plus 4 squared. And then it's the square root of 4 squared, but square root and squares cancel out, so then the answer is 4. So if you plug those numbers into the Pythagorean theorem, you get 4 squared plus 3 squared equals x squared. So then it's 16 plus 9 equals x squared. So then 25 equals x squared. And then you find the square root of 25.
So the answers are 4 and 5. Let's go in. Hey, we're almost to geometry. All we need to do is cross this graph river.
But the polygon's too far apart. How are we gonna do it? Math!
We can use transformations, a change in position, size, shape, or a figure. The image before the transformation is a pre-image, and the figure after the pre-image is the image. Specifically, we could use rotation. A rotation is based on a point. Each point and its image is the same distance from the center of rotation or point. Now move on to the pre-image of the triangle. After that, hop onto the image of the triangle. Now step onto square CBAD. We're going to use a reflection, which is an image that is moved across the line called the line of reflection. Each point and its image are the same distance away from the line of reflection. Okay, so now you're going to move to the image of ABCD. Lastly, we're going to use a translation on rectangle JKHI. So move on to that rectangle, and we will move all the points in the same direction for the same distance to the other end of the river.
Yay! We made it!
Made it!
So, Uggs, why do you always wear Uggs?
Well, you see, I love winter. So whenever it's winter, I wear Uggs. So whenever I wear Uggs, it's winter.
I think there are certain conditions to make a statement like that.
Hey, we'll learn that next chapter.